Okay, so I'm gonna work on chapter 965. A uniform thin wire is bent into a semicircle of radius r. Determine the coordinates of its center of mass with respect to its origin of coordinates at the center of the full circle. Okay, first I would draw a diagram of a semicircle, and its origin is the origin at when it was respectively when it was a full circle. So that would be 0, and that would be the x and the y. Now we know that the radius from here to here is r, and we're trying to find. No, also we know that the center of circle in the x direction is at 0, and we want to know where it will land at the y-axis between here to here. So for us to do that, we need to find the mass of this small ds. I want to say that's a ds, and at that corresponding ds, we will have a corresponding d theta. So ds is equal to rd theta, and dm, the mass of this small part, is lambda ds. The lambda is mass of the total length, but we know that the semicircle has a length of pi r. Now dm will equal to lambda r d theta. Now our next part is to set up the equation to find the center of mass in the y direction. So the position of center of mass in y is equal to 1 over m summation phi over 0 y direction dm. Now this y is the value from where this ds is and the distance from here to here. Now as we can see, as this theta will increase, the distance will also increase. So we can see that's in sine relationship. So sine SOHCAHTOA, opposite of hypotenuse, is the corresponding y distance. So we will have to rearrange that into 1 over m summation pi 0 r sine theta, and dm we use this dm, which is lambda r d theta. And from here we can take out the constants, which are these two r's, r squared, and a lambda from here. So r squared lambda m summation pi 0 and sine theta d theta. Now we can integrate this by looking at the theta, which will lead us to negative cosine theta multiplied by r squared lambda over m if the highest point is pi and the lowest point is 0. From here we have to draw a cosine graph, which is easily drawn like this, where this is 0 and this is pi. This will be 1 and negative 1. So if you plug pi into the theta, we will get r squared lambda over m over minus multiplied by minus 1, and that will give us a positive, minus r squared lambda over m, and you plug in a 0 here, that will give us a positive 1. So that will be 1 and then minus positive 1. Now, if we distribute everything out, we will get r squared lambda over m plus r squared lambda over m, which gives us 2r squared over times lambda over m. Now, from here, we said that lambda equals to m over pi multiplied by r. If we add that equation instead of this lambda, we will get 2r squared multiplied by m pi r over m. These m's will cancel out, and another r will cancel out, which leads us to having an equation of 2r over pi. This is the position of the center of the mass in the y direction, which is right here. So it would be 2r over pi. That was the answer for 65 on chapter 9.